So, yeah, 2 o'clock, I'd say let's start. Welcome to the Tech Talks. Thanks for coming. My name is Andreas Schmidt. I work for Think Forward. Think Forward is part of the Cassini group, a group of several companies dedicated to IT consulting, to IT software development, to IT architecture. And today's topic is from web development to the Internet of Things, prototyping for fun and profit. And at Cassini, and especially at Think Forward, we love coding. We love software architecture, and creating new things. And we've done this within the field of web development for quite some years now. And now we're turning to IoT, the Internet of Things. And well, first steps with the Internet of Things can be fun. Playing with maker boards, for example, is great fun to build stuff. But also companies are turning into building IoT solutions, and that's the profit part. So what is the Cassini Group? We are founded in 2006, that's over 11 years ago, with the inception of Cassini Consulting. This was the first nucleus, and we've grown in the last 11 years up to 250 employees. We have 9 offices around Germany, all major cities. And what is the Cassini Group? First of all, it's Cassini Consulting. These are the consulting guys doing IT consulting, strategy consulting, project management, quality management, conception, and a bit of implementation. And there's the Aleri Solutions. These are the implementation guys. They really love coding. Well, the Cassinis do probably too, but the Aleris do even more. Scoop IT is our own recruiter, and I am with the last one, the DIG, the Digital Incubation and Growth. This company is our own incubator, and that's where Think Forward, the project Think Forward, comes from. So if you want to learn more about Cassini, the group and its companies, come to our desk. We're sitting at the front. We're happy to talk to you if you want to know more. So what about Think Forward? Think Forward and its inception are based on a bunch of IT projects that we did with Cassini Consulting and Aleri over the last years, where customers of ours started to build or enhance IoT solutions, IoT products, or start to build for the embedded world. And that was the reason for us to invest in this field as well. And quite some people say, okay, IoT, the Internet of Things, this stuff is around for years. It has been around for years because machines always collected detailed data like telemetry and stuff and sent it to some other device for analysis and stuff. So this is not completely new. And this is sort of the old school picture that maybe that IoT is behind. Depicted is, for example, processes within factories or caches in retail market, but they are used to send their data to some local IT, typically maintained within the company, within own data centers. So this is like pre-2005 up to maybe 2010. That's how IT was built. Nowadays, we're used to using the cloud. So there's large cloud providers like Amazon, AWS, or IBM, or Microsoft Azure, and you name it. And we connect our devices to cloud service, to APIs, to web services. On the other side, devices are connected to cloud services as well. But it's always the cloud in between, because that's where the computing power lies. That's where the analysis can be done. That's the home of, say, big data and stuff. And this is typically built as of now. That's how IoT solutions are typically built. You have small sensory data coming from from your smartwatch, from your phone, from whatever installation you might have in your smart home, if you have such modules. And typically, they send data to some cloud service where you can view it in a dashboard or do other things with it and connect that cloud service with other cloud services to implement new use cases. And we're a bit on a verge there, because the upcoming Internet of Things, some people believe that it's more going to look like this, that maybe we still have the cloud as the provision of services, of APIs, but it's only part of the overall solution, because devices may start to talk to each other. And they do not necessarily need the cloud anymore. So this could be a potential use case for that. And one can see the way into this solution, for example, by looking at blockchain. Blockchain is not a single application anymore that runs in a single location. It is a network of applications and nodes that form this system. And this is a bit more like the upcoming IoT. And the upcoming IoT is not without problems, because what it would need is, of course, a ubiquitous connectivity over the internet, using, for example, TCP/IP as a basic networking protocol. And not all of the small embedded IoT devices are capable of doing so, for example. So that's still some challenges ahead. But most people believe that the IoT market is going to be big. It's going to be huge. And you can look at some studies or analysis papers. Typically, they say, oh yeah, by the year of 2025, we reach an installation base of so many devices. Billions of devices are going to communicate with each other. And most of these analysis papers deal with either the numbers of devices, or the fact that many companies invest a lot of amount of money into these solutions. But it's not really easy to build IoT solutions. Coming from web engineering, there are a bunch of methodical and technical barriers in developing these solutions. And we've composed a small map of buzzwords around the IoT. And this is totally mixed up between protocols and data formats and what else do we have here? Radio frequency stuff. So the stack that comprises an IoT solution is not completely different from a web stack. You find similarities there, but it's still different enough so that you cannot really jumpstart into it. You have to look at quite some different things. For example, programming languages. Maybe you are used to programming in Java, in JavaScript, C#, maybe Go, but looking at these constraint devices, the small chips that are programmed directly, most of that stuff is programmed in C and sometimes C++. And plain C is not really fun when you have a background of Java or JavaScript and are used to higher level constructs such as package management and libraries and unit testing and stuff. That's all nice in the more modern languages. C and C++ have these features, not that sophisticated. Sometimes they don't have it at all. So that makes it difficult to program for these languages, for these devices. Another key concern is interoperability, security, and connectivity. And that's from a developer survey. And another developer survey, quite interesting because it's very up to date, is State of the Developer Nation of this year, third quarter. It's free for download. The URL is below. And I took out one sentence that matches for IoT. what makes a new device hard is the combination of hardware and the software. It's not software alone, it's not hardware alone, it's more of the two. You need to put your specific firmware on a specific hardware target, and that's what makes it difficult. But it's definitely needed, because at the software level, that's where the added value is. The device itself is not smart, it's the software that you put on it that makes it smart. And from that sort of background comes our mission. And we're aiming for bringing the speed, flexibility, quality, technology, and in the end, the people from the internet space to the IoT space. So bringing web developers used to modern languages, modern tool chains, to the point where they can easily program embedded devices. And we're building tools, developer tools, so we have a business to developer approach. And our tool chain is quite modern from the technology perspective. We program in Go, Google's Golang, using containers, using cloud, to build tools that makes life easier. And yeah, supporting services is typically consulting. And we have a training format. So it's a 2 or 3 days kickstart training. We say when you're a web developer and used to programming for the web, then after 2 days, you'll be able to program for small devices and can start to build IoT solutions. And that's the sort of slogan, everything you need to get up to speed with IoT. That's the same slogan that we used in our webinars. We're aiming to do a webinar each month introducing into the development of IoT solutions. These are advertised at Xing and LinkedIn. So if you want to join, participation is free. And yeah, that's the webinar series and the seminar series where we sell our trainings. So why IoT prototyping? That was the title, IoT Prototyping for fun and profit. Prototyping comes in really early project phases where you know that you want to build an IoT solutions and you know that you do not start with the final thing, but you start with a prototype. You have ideas in mind and you want to put these in a prototype to validate that it can be working. So it's the early phases. And the goal is, given a limited time frame, not half a year, not 4 months, not 2 months, maybe just 2 or 3 weeks, thinking in agile sprints, for example. So given that limited time frame, we want to learn as much as possible about the solution that we want to build. And learning is about both technology, about the product, about development processes, but first and foremost about our customers, our market. Is there a market to sell our product? That's the core question. And the prototyping phase aims at learning the most as we can from a given time frame. So this is inspired by lean startup principles and the idea of the minimum viable product. You probably heard of that. Do not build the solution end to end, which would take much too long. Instead, build an MVP, a minimum viable product that you can take and go to your customer and ask him or her if the product is valid and is an add-on. So the core is about formulating ideas, what to build within the prototype. Build that as an MVP. Don't go too far with that MVP, just a small minimum product. Then go out to the customer, get feedback from the customer, and yeah, then it's the next iteration. Incorporate the feedback from the customer into the prototype for the next round. Rinse and repeat, and as good as you can, aim for short cycles. Do not run a prototype phase for like half a year, maybe just only for 2 weeks, because that's the faster that you can get, the more you can learn, and the more you can iterate. So that's where the limited time frame is important. And yeah, typically you have some sort of ramp-up time. When you start something new, you have to look at your tool chain, what integrated environment to use, what tools to use. And this can take time, and I have only limited time during my prototype session. So what can we do? Looking at embedded device development, there are typically a large number of possibilities there. So from the left, this is the professional part, typically meaning custom PCB. So you're using a tool to place your components, your MCU, your chips on a PCB, then send this design to someone who is able to produce this PCB, and this typically takes at least 2 weeks, sometimes more, depending on where the factory is that produces this thing. So this is okay for professional development, but that doesn't really help us in prototyping because we have a limited time frame. On the other hand, on the right side, that's the educational and the maker hardware. I've taken a photo of an Arduino Uno. You probably know that, the Arduino boards. These are readily available. They're quite cheap, not that costly, and you can try out a whole bunch of things with these. That's fine. But they do not provide a path into professional development. No one would build a professional product with such a board. So there must be something in between, and that's the hardware from professional vendors. The photo in the middle is a photo from ST. They're professional chip makers, and they have their own development boards. So they can quite easily be programmed, and they have the path to some form of professional product development. And when we go to customers and do these IoT prototyping workshops, we typically start on the right side. We take educational hardware, maker hardware, which is Arduino compatible, because that's the most easy thing to program with. And we say, okay, if you're a web developer, we get you to the point to developing for this very easily. 2 days, and after that, you can build your own solution that you planned in your company. And these are some impressions from the workshops that we already did. Typically, is in the middle, it's a bunch of web developers with various skill sets around Java, JavaScript, some more front-end, some more back-end, but they're really enjoying programming for these small devices. And we have what we show at the table in the front too. Our upper right is our prototyping device kit. I'll show it in detail there. So that's where we start to learn coding for embedded with. So what are the components? We say we use Arduino compatible hardware. So we're using this little one. That's a Node MCU. It's an ESP-based board, 32-bit. And the good thing about this board is it has integrated Wi-Fi. So very easy to program, and you can just connect to your guest Wi-Fi and start communicating there. Really easy stuff. And it's compatible, well, mostly compatible, 98% compatible to the Arduino framework. So most of the code that you find in the internet regarding Arduino sketches, you can put on this as well. And it's also able to run MicroPython, eLua, and embedded JavaScript as well. So, but that's just the board. I mean, that's just an MCU. What about the rest? We've chosen the Growth Kit from Seed Studio. I think they're Chinese-based, and they have a large offering of over 100 sensors and actuators. For example, motion sensor, gas sensor, moisture sensor, vibration sensor, relays, motor steppers and stuff, and so on. And the good thing about the Growth Kit, what helps us in our IoT workshops is that it's pluggable by standard connectors. You don't need no breadboards, no soldering required. You could if you want to, no problem, but you don't have to. And that makes it quite easy for building sort of IoT solutions in a short time. Of course, these are like table prototypes. They work nicely on a table in a controlled environment, but if you go outside, maybe they don't work anymore because the light is too heavy or it rains or whatever. But for prototyping in an office, this is quite cool. Yeah, over 100 sensors, so really great choices to implement stuff with it. How to code that? Two possibilities. First is, maybe you know the Arduino IDE, installable for Mac, Windows, Linux. Really great if you want to try out just small sketches. You could download from the internet, paste the code into the sketch editor, add a library, and you're done. And typically this compiles on a web service, so you need cloud connectivity and then flash to your board. Works. Is fine. Again, no path into some more professional development, and this is why we choose the nice thing on the right side. It's Platform IO. In the end, Platform IO is a management tool chain for the embedded tool chain. So this thing installs compilers and linkers, cross-compilers, and it installs the right compilers for the right targets, for the right chipsets and stuff. So these guys have done a great bunch of work that really helps. And they integrate into common IDEs like Atom, VS Code, C-Line, Eclipse, and so on and so on. And they have some nice functionality, added functionality there. So in the end, in our prototyping workshops, what we do is we teach people how to install this stuff, what coding for embedded is really about, what the differences are, what you need to know when coding for constrained devices, constrained networks, and constrained environments, and give a path into some more professional development there. Yeah, and that's we're at the core of the offering that we might have for you. If you and your team might want to build something with IoT, something with embedded boards, something with communication, with sensors, with actuators, come to our desk where we can give you these prototyping kits. And if you can tell us what you want to build, we have a collection of sensors and actuators, and we're happy to give them to you so that you can build your solutions. So if you want to, you're invited, come talk to us. And this concludes the end of my talk. Thank you very much.